Up to?
Lower constant proportion.
No. After that also you have completed so much things like atomicity and I think
Just the radius of an atom.
radius of an atom we are completed. This is what, how do atoms, this also we complete time, monoatom, atomicity we didn't complete atomicity. The number of completed, no? And this molecules and of compounds. Okay, so I think we have to continue from here. Yes. Hare. Okay. So now let us see about the ion. What is mean the ion? ION, ion. What is the difference between the atom and ion? Yes? Akansh, what happened?
An ion is the atoms which are lost, used, or take their electrons.
So here you see, atom means it is a neutral. Neutral means what? The number of protons that are present in the nucleus is equal to number of electrons that are revolving around the nucleus. This already we studied. Okay, atom consists of protons, electrons and neutrons. Protons and neutrons are present in the nucleus. Okay, and electrons will be revolving around the nucleus. So the number of electrons revolving around the nucleus is equal to the number of protons present in the nucleus. Okay, so number of protons present in the nucleus. So the positive and negative charges are equal. So generally they are called atoms. Okay, but most of the atoms in the nature, like you say periodic table also, so these are unstable, they are not stable. Okay, so due to that what happens, they may lose or gain the electrons to attain the stability. They may lose or gains the electrons, means what, they can give the electrons to some other atoms, or sometimes they may take the electrons from the other atoms. So when the electrons loses or gains, means when the electrons transfers from one atom to another atom, then what happens, these neutral atoms becomes charged, becomes what, charged. Okay, either positive or negative. So these charged particles are called ions. Is this clear to you, ions? Yes or no? Okay, so for example you see here sodium is there. Okay, here I am writing sodium. Sodium atomic number, sorry, okay, symbol is Na. Its atomic number is 11. So what we write, the electronic configuration is 281. Do you know the electronic configuration, or we discussed about the electronic configuration? Akash, are you there? Okay. So here what happens, here actually atomic number of sodium is 11, means this sodium consists of 11 protons and 11 electrons. So plus 11 minus 11 is equal to net charge is 0. Net charge is 0. But now what happens, to attain the stability, sodium loses one electron, means what, it will give one electron to other atom. When it gives one electron, so here you can see sodium is giving one electron, minus one electron. So it is giving one electron. When it is giving one electron, already we have seen that it has 11 protons. Yes or no? So 11 protons. Okay, and 11 electrons were there, but this is giving one electron. Okay, so now when it is giving one electron, so number of electrons will be left to only 10 electrons. Okay, number of protons are 11, number of electrons are 10. So now protons carries the positive charge, so plus 11. Electron carries the negative charge, so minus 10. Plus 11 minus 10 is equal to what? Plus 1. So sodium, okay, now when it loses one electron, now the sodium, okay, acquires 1 unit of positive charge. 1 unit of positive charge. Now it is not called as an atom, okay, it is called ion. Is this clear to you? Okay, so ion means a charged particle. It may be positive or negative. Okay, so ions are of two types, positively charged ions and negatively charged ions. Generally, positively charged ions are called as a cations. What they are called? Cations. And negatively charged ions are called as a anions. So positively charged ion is formed by losing of one or more electrons. If one atom is losing, okay, or giving one or two electrons to the other atom, then it becomes a positive charge. Okay, and negative charge ion is called anion. So how it becomes an anion? When it takes one or more electrons from other atom. So it takes number of electrons from other atom. So the number of electrons becomes more than the protons present in this. Okay, so due to that what happens? The negative charge becomes more than the positive charge. So this becomes negative charged. Okay, this is negatively charged particle called as an anion. So very simple and easy. Which loses electrons, that become positively charged. Which gains electrons, that becomes negatively charged. That's all. Is this clear to you? So once again see here now. So ion, it is an electrically charged atom or group of atoms. Sometimes group of atoms also will be there. Okay, it is formed by loss or gain of one or more electrons, okay, by an atom. So generally ion is nothing but a charged atom, okay, charged atom. So here generally it becomes, generally atoms are neutral, okay, but here it becomes a charged particle either by losing or gaining the electrons. So ions are of two types, because charged particle we said, you know that charge is two types of charges are there, yes or no? That two types of charges are there, one is called a positive, other one is called a negative. So one charge, one ion is called as a cation and second one is called as a anion. Cation and anion. So cation is what? It is a positively charged ion. See here, cation means what? It's positively charged ion and is formed by loss of one or more electrons from an atom. So cation is formed by loss, by giving one or more electrons. If it loses one electron, it becomes unipositive. It becomes what? Unipositive. Uni means what? Single, one. If it loses two electrons, it becomes dipositive. If it loses three electrons, it becomes tripositive. So how many electrons it's losing? That amount of positive charge it's gaining. That units of positive charge it gains. Is this clear to you? Okay. So now you see, for example, sodium. Sodium is losing one electron, so this becomes here plus 1. Okay, only one plus is there. For example, you take some other atom. I am taking a magnesium. For example, I am writing here magnesium. This magnesium can lose 2 electrons. Can lose how many electrons? 2 electrons. When it becomes 2 electrons, how can I write this one now? Yes, Mg plus 2. We write like Mg plus 2. So we can write like this, because here it is losing 2 electrons. Okay. If it loses 3 electrons, we can write plus 3. Okay. And when it is only one charge is there, this is called unipositive. If it is 2 plus positive charge there, dipositive. If 3 are there, tripositive, and so on. Is this clear to you? Right. Now, how the positively charged ion forms? Similarly, a negatively charged ion also will form. If there is a positive charged ion, there should be a negative charge ion also. And negative charge ion is exactly opposite to the positive. So here positive charge ion, how it is forming? By losing the electrons. But here negative charges, how it will form? By gaining the electrons, means by taking the electrons. Here it is a negatively charged ion. Anion means what? Negatively charged ion, and is formed by gain of one or more electrons. Gain means what? Taking of one or more electrons. So for example, you say, here you see chlorine. Okay, chlorine atomic number is 17. Chlorine atomic number is what? 17. So here we write the electronic configuration as 2, 8, 7. What do you write the electronic configuration here? 2, 8, 7. So in the outermost shell, see only 7 electrons are there. So it becomes stable if it will have 8 electrons in it. Already we discussed, I think. Okay, octet rule. According to octet rule, any atom which possesses 8 electrons in its valence shell, that becomes stable. But here only 7 are there. So what happens? It will gain 1 electron, takes 1 electron. So now what happens? This chlorine gains 1 electron. So it's taking 1 electron. So it's taking 1 electron, then it will negative electron is what? Negatively charged particle. So now it acquires the negative charge. So this becomes Cl minus. So this is called chloride ion. What it is called? This is not called as a chlorine ion. You should not call it as a chlorine ion, but you should call it as a chloride ion. Is this clear to you? Similarly, for example, you take oxygen. Okay, for example, you take the oxygen. Here I am writing oxygen. Oxygen atomic number is 8. Electronic configuration we write it 2, 6. So here also in the outermost shell only 6 electrons are there. But I said that 8 electrons should be there to attain the stability. But only 6 are there. So to attain the stability, it requires 2 more electrons, right? So it will take 2 electrons. So when oxygen take 2 electrons, okay, plus 2 electrons, then it becomes what? O minus 2. Because it's taking 2 electrons, so I have to mention that minus 2. So it has 2, okay, electrons gaining, so it becomes minus 2. And this is called oxide ion. What it is called? Not oxygen ion. You have to say oxide. So generally, whenever the non-metals, okay, non-metals, remember here, non-metals, okay, like oxygen, nitrogen, fluorine, chlorine, bromine, iodine, whatever it may be. So whenever the non-metals gains an electron, okay, gains an electron, now it is not called as their own ion, like nitrogen ion or chlorine ion, not like that. You have to say that chloride ion, nitride ion, okay, sulfide ion. Is this clear to you? Remember that it should come IDE, IDE last, okay. Yes. No. Here it is short of how many electrons per octet configuration. So here in the outermost shell there should be 8 electrons. So here it is 6 electrons are there. So it should gain 2 electrons only, not gain more than 2 electrons. Oxygen, because in outermost shell how many electrons are there? Only 6 electrons are there. It requires only 2 electrons. So that's why it will take only 2. It cannot take more than 2. Is this clear? Now similarly, chlorine has a 7 electrons. So it is short of only 1 electron. So it will take only 1 electron. It cannot take more than 1 electron. Is this clear? Like that you have to check. Okay? Right. You can take the screenshot of this one. Done? Right. Now see here. Here these are the ions, okay, some cations, some anions, and here cations or anions group of atoms, okay, means what? More than 1 or 2 atoms, more than 2 atoms, okay, 2 or more than 2 atoms also, sometimes they combine, and that also will have a charge either positive or negative, okay. So they are called polyatomic ions. What they are called? Polyatomic ions. Poly means what? Many, okay, 2 or more, okay. Atomic means 2 or more atoms with a charge, either a positive or negative. So they are called as polyatomic ions, okay. So normal ions are polyatomic ions. So this is very important, okay, to write the chemical formula of any compound, okay. So you can write the chemical formula of any compound by using this one only, okay. So that's what this is very important. So just to see here, here you see sodium, okay. Sodium, it's losing 1 electron, so that's what it become Na plus. Okay, it's becoming Na plus. Okay, so here it is, as it is losing one electron, so we take the valency of sodium is 1. If it is losing one electron, we take its valency as 1. If it is losing 2 electrons, we take its valency as 2. If it is losing 3 electrons, we take its valency 3. Similarly, if it's take 1 electron, here also we take the valency is 1 only. If it is taking 2 electrons, then we can give the valency is 2, like that. Okay. So here potassium ion, so it's losing plus 1 electron, so plus only 1 plus charge is there, so its valency is 1. Silver, here also 1. See, copper had 2 chances. Copper can lose 1 electron also, copper can lose 2 electrons also, depending on which it is reacting. Okay, that we will learn in the higher classes. So here you see in the bracket, if they write Roman number 1, the meaning is what? It is losing 1 electron, so its valency is 1. Okay, here you see copper, here 2 is there. Okay, Roman number 2. Roman number 2 means what? It losing 2 electrons, its valency is 2. Is this clear to you?
So what's the atomic number of copper, sir? What's the atomic number of copper, sir?
Atomic number of copper is 29. Copper is 29. Atomic number is 29. Okay?
Yes.
So like that. So these are the unipositive, means valency with 1. These are the dipositive, means valency 2 here, and these are the tripositive, so valency is 3 here. Okay. Now similarly here also, let's come to here also. Okay. These all are so minus only 1 minus is there. So these are also unipositive. Okay, this valency is 1 till here, and its valency is 2. Its valency is 2 because minus 2 is there, so I have to take the valency 2. And nitride minus 3 is there, so its valency is 3. Its valency is 3, its valency is 2, and these all valencies are 1. Remember this one, very important. It helps in writing the chemical formulas. Now these are the ions of atoms, means single atom. Okay, monoatomic ions. Now here you see a group of, okay, so these are called polyatomic ions. Polyatomic ions. Okay, polyatomic ion means what? If 2 or more than 2, okay, atoms are there, then that is called as a polyatomic ion. So here you see ammonium. See, this is ammonium. Okay, this is hydroxide, OH minus hydroxide. NO3 nitrate. This H hydrogen carbonate HCO3, this is also called as a bicarbonate. Hydrogen carbonate is also called a bicarbonate. Bicarbonate is also HCO3, and also only 1 minus is there, so that's what these are also valency is 1. Valency is 1. Clear? Okay. Now this is carbonate CO3, sulfite SO3, sulfate SO4, and minus 2 is there. So these are valencies, or just to write it 2, no need to write minus, just to write it 2. Okay. Now phosphate PO4 minus 3 there, so its valency is 3. This is a very important chart. Okay, Akash. So it's a, because in the coming classes, now we are in 9th, so in the 10th class, are you CBSE or SSC? Okay, whatever it may be. So CBSE, yeah? SSC, yeah, whatever it may be. So in this, so many chemical reactions are there. Okay, nearly if you observe the 10th class textbook, it may be CBSE or SSC, nearly 150 chemical reactions are there. Okay, so these chemical, to write these chemical reactions, first you should know how to write the chemical formula first, okay, of a compounds. Then you should know how to balance them. Okay, this all you will learn, but to write that perfectly here, you need to know these things are very important. Okay, most of the chemical compounds which are used in the 10th class, okay, 10th class up to 10th class, so these, okay, ions are sufficient to you. Okay, these ions are sufficient to you to write the chemical formulas up to 10th class, and of course some extra also will be there, that we can discuss later. Okay, so take this screenshot, okay, and you have to write this in your notebook. and learn, okay, practice. Then I will explain you now how to write the chemical formulas by using this chart. Okay, so take the screenshot of this one.
Sir, how should we write the electronic configuration of copper, sir?
What?
How to write the electronic configuration of copper, sir?
Copper sulfate, huh?
No, copper, sir.
Copper, copper electronic configuration is, right, you have to write like this. Okay, so if you go to the higher class, actually you are in 10th class, no? So write like this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. This is actual electronic configuration of copper. Okay, so if you count this upper numbers all, so you will get to 29. So 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 6, 18 plus 1, 19 plus 10, 29. So these upper numbers you will count, so you will be getting the 29. So that is the actual electronic configuration of the copper.
Yes, sir. We are writing K element shells for the.
In the K element shells, what you write here? This is K shell. So write 2. This is L shell. 8. Here you see here, this and even this also 3D is there. Okay, 3D. So 3, 3, 3. So you write here 18 electrons, and the fourth shell you write 1 electron. 4, 2, 8, 18, 1. 2, 8, 18, 1. So if we add this, all this, again you will be getting the 29 only. Clear?
Yes, sir.
Done? Right. So you know that number of maximum number of electrons that can be accommodated initially is given by the formula 2n square. Do you know this formula? So K shell, L shell, M shell, N shell. K value is 1. 2 into 1 square. So you will get 2. Here L shell is 2. 2 into 2 square. That is 8. Here 3. 2 into 3 square. That is 18. So you will be getting here 18.
Yes, sir.
Like that. Okay, so this is a very important, you have to learn this one. Okay, here now writing the chemical formula. Okay, so Akash, your work is that today I am going to explain you how to write the chemical formula by using the previous table. Okay, this table. Okay, and after that you have to write at least 25 chemical formulas yourself, and that is a homework for you. Okay, because in the next coming test, even next class, tomorrow only next class, I will just ask you to write the chemical formulas. Is this clear to you? Okay, chalo. So what I am doing is now, okay, I will explain how to write the chemical formulas. So here actually procedure is there. Okay, how to write. So write the symbols formula of an element, so that symbol of the metal or positive ion is on the left side. Okay, I will explain so that you can understand this in reading instead of that. If I want to write the chemical formula of hydrogen chloride, okay, so I want to write the formula of hydrogen chloride, which is there in the board. That I only first I will explain you, and then I will go for the next hydrogen chloride. Okay, so first you have to write the symbol of hydrogen, then you have to write the symbol of chlorine. Okay, symbol of hydrogen and the symbol of chlorine. Okay, so hydrogen symbol is what? H. Chlorine symbol is what? Cl. Then you have to check what is its valency. Okay, so in the previous here hydrogen +1 and chlorine, where is the chlorine? So chlorine is -1. So you have to write like this. Okay, in the next step you have to write their valencies. No need to write total this one. So just you write the valencies. So hydrogen valency is 1, chlorine valency is also 1. Now you crisscross like this. Okay, so hydrogen, this one comes here, and chlorine, this hydrogen one goes there. If both are same number, you can cancel, so you can write HCl. So that's all. That is the formula of hydrogen chloride. So here hydrogen, its valency is 1, chlorine, its valency is 1. So hydrogen valence you take there, chlorine valence you bring here, and you can write HCl. If same one is there, you can make cancel. Clear to you?
Yes, sir.
Now hydrogen sulfide is there. So see here, hydrogen sulfide. First you have to write the symbol of hydrogen. So here I am writing hydrogen symbol is H. Sulfide means sulfur, S. What is the valency of hydrogen? 1. You write at the top. What is the valency of sulfur? 2. So write at the top. Anywhere you can write. Now you bring this 2 to hydrogen. This one you bring to sulfur. Exchange. This is called crisscross. So now hydrogen, this 2 is coming here. So write it 2. Yes, sulfur, this one is coming here. 1 means you need not write. So that is H2. Yes. So this is H2. Yes. Clear?
Yes, sir.
So similarly, magnesium chloride. Okay, magnesium chloride. So here I am writing here magnesium chloride. So first write magnesium, then you write the symbol of chlorine Cl. You should know that magnesium valency is 2 and chlorine valency is 1. Again you crisscross here. So this one bring here, but you need not write 1. If it is only 1 is there, you need not write. And here chlorine, this 2 you bring here, MgCl2. This is the formula of magnesium chloride here, MgCl2. Right?
Should we avoid the signs, sir? Whether they are positive or negative, should we avoid?
You have to avoid the signs. Signs are not required. Signs are not required. Okay? So here carbon tetrachloride, carbon C, chlorine Cl. Carbon valency 4, chlorine valency 1. Crisscross. So you'll get. Is this clear to you? So this 4 formulas you write now. Take the screenshot later, but you can write them once you write it, so that you will get practiced here.
Yes, sir. Done, sir.
Done? Okay. Now for example, if you want to make a formula between magnesium and oxygen. So write the formula of magnesium oxide by crisscross method and tell me what is the formula, how is it? Magnesium oxide. So by using crisscross method, first what you do?
Sir, you want to cancel G2O2?
Very good. Magnesium valency 2, oxygen valency 2. If the same numbers are there, you can cancel it. Right. Very good boy.
MgO.
MgO. That's all. Clear now? So take the screenshot of this one first. Right. Now, yes, some other formulas also there. So you try this one. Okay. Calcium oxide, aluminum oxide, sodium nitrite, calcium hydroxide, sodium carbonate and ammonium sulfate. So these formulas you try without seeing on the board, on the screen. Okay. So just take the names.
Yes, sir.
Just write the names, don't see on the screen, and try and check your answer with this formula whether it is correct or wrong.
Okay, sir.
Write these formulas. Yes.
Sir, for neon electronic, what's its atomic numbers are neon?
Neon, huh?
10 or is it 10 only, sir?
Neon, huh?
What have 10, sir? 10 which element has 10 as its atomic numbers?
Neon only. With atomic number 10 is neon.
Yes, sir. We should write in electronic configuration as
2 and 8.
Huh?
2, comma 8.
2,8. Okay, sir. And its value is 0, sir.
Its valency is 0 because it's not, it is octet configuration is full, so its valency is 0.
Only we have octet configuration only, sir.
Yeah, octet and duplet also, like helium. Helium has only 2 electrons, but still it is stable. Okay, so this also will not react with any other element, so its valency is also 0. Helium. Helium is 0. Right?
Yes.
So take the screenshot of this one, and by using this this table, at least 25 chemical compounds and formulas you have to write. Is this clear to you?
Yes, sir.
So tomorrow I'll ask some compounds and you have to write the names. Okay?
Okay, sir.
Chal. Once you have taken the screenshot for this one?
Yes, sir. Thanks.
Okay then. Today with this we'll stop. Okay. So tomorrow also we practice the problems only, these formulas, and then we go to the next topic, molecular formula and molecular masses in the next class. Right?
Yes, sir. Thank you, sir.
Okay then. Bye.